Hi again, guys. Another problem here. The man attempts to pull down the tree using the cable and a small pulley. Small pulley is a synonym for frictionless pulley. And by the way, majority of the problems that we are dealing are frictionless pulleys. That's it. What is the meaning of a frictionless pulley? That I know that if this is the frictionless pulley, then we're gonna have here a tension that is gonna be equal to this tension in magnitude. That's what it means. And I know that this force here is 60 because that's what the problem is telling you it is there. So I'm going to solve this problem just by doing summation of forces in X and Y. I could try to do this in the same way that I tried to tell you in the previous problem by rotating this and considering this an axis here. But I'm going to try to do it like if I don't know that. So I'm going to assume that this is X and this is Y. In other words, if this is my particle, this is going to be the X direction here, and this is going to be the Y direction. If I do that, remember we have two equations, summation of forces in X, summation of forces in Y. So let's start with summation of forces in X equals 0. The X component for this tension will be T, negative T cosine 20. So let's do that. Negative T cosine 20. That's this here. Now for the other tension, the X component for the other tension, for this one, the angle will be 20 plus theta. So it's going to be minus T cosine of 20 plus theta. And in the X direction, this other one, this force of 60, basically will be this direction here. The component will be to the right, so that's going to be plus 60 cosine of 30 equals 0. And now we can solve this, and we can say, okay, I'm gonna regroup this. I'm gonna get common factor T, and I'm gonna say this is, and at the same time I'm going to pass it to the other side to get rid of these negative signs here. So it's gonna be T cosine 20 plus cosine 20 plus theta, and because I'm passing this to the other side, equals 60 cosine 30. And I'm going to keep this as my equation number 1. I could solve this and put a number here and put a number here, but I just don't want to. Now we're going to do summation of forces in Y equals 0. So if I say summation of forces in Y equals 0, then what are we getting here? The first T, this one, the vertical component, is going to be T sine 20, positive because it's pointing up. The second T, which is this one, is going to be T sine of this angle, positive as well. T sine of 20 plus theta, positive as well. And the Y component of this force here will be 60, negative 60, sine 30. Equals 0. Now, same thing that I did here, I'm going to redo here. I'm going to pass this to the other side, and I'm going to take common factor T. So it's going to be T sine 20 plus sine 20 plus theta equals 60 sine theta. And that will be my second equation. Now, I'm going to divide equation 2 by equation 1. Let me put here the the equation one, I'm gonna put it in red so you can see it, the difference. It's gonna be t cosine 20 plus cosine 20 plus theta, and it's gonna be equal to 60 cosine 30 degrees. Now, if I divide this and these are gonna cancel out, this 60 and this 60 cancel out, and this sine divided by cosine becomes tangent. So basically what I have is this, sine 20 plus sine 20 plus theta divided by cosine 20 plus cosine 20 plus theta equals tangent 30, but I'm going to pass tangent 30 to this side, so it's going to be tangent minus tangent 30 degrees equals 0. And I get this freaking weird equation right there. But you don't have any problem with that. I know, oh, I don't know how to solve that, because yes, you do know how to solve that, because we did problems like that before. We're going to use the all good trial and error. Once again, if you have a calculator and your professor allows you to use it, like this one, then you can also use the solver function, and you can put that equation over there and say solve for theta, and the calculator will give you the result. If you have a regular TI-83, TI-84, one of these calculators, which by the way, I have an app in my phone that is awesome. If they allow you to use that, you can find this app. Look, it's exactly the same thing, the same calculator, the TI-84 Plus. If your professor allows you to use it. Now, if your professor doesn't allow you to use it, the calculator is not allowed, we can use trial and error that never fails. And the only thing we are going to do is this. I'm going to start guessing, and I'm going to guess that theta is 30 degrees. Just guessing. If theta is 30 degrees, and I put here 30 degrees and 30 degrees, I should get 0, because that's what I'm hoping to get, 0, right? So let's copy this equation here. When you copy the equation, this is critical. You have to code the equation and use the parentheses and everything else that you need to use correctly. So I'm going to use a parenthesis, and then I'm going for the numerator, this external parenthesis here, and I'm going to put sine 20, close the parenthesis of 20, plus sine, now it's going to be 20 plus, I'm going to put 30 as initial value for theta, and I'm going to close the numerator, divided by, I'm going to start with the numerator now, the denominator, open parenthesis for the denominator, cosine 20, close parenthesis, plus cosine 20 plus, I'm going to use 30 as the first approximation, minus, I could put a number here, but why? If the calculator can handle that for me. And then I hit enter. So if I assume as first trial theta equals 30, I get 0.1229. I know the angle should be smaller than that. But even if I don't know, let's try theta equals 25 degrees. So then you go up, whatever your equations are, right there, and you start changing the 30 that, remember the formula. So I have in the numerator, I put 30 here, but that wasn't 30, it was a guess. I'm going to put 25 as a guess. And in the denominator, I'm going to put here as well 25 as a guess. And I'm going to hit enter. And now it's 0.0597. You see, it's approaching 0. And 0 is what I'm supposed to get here. Now let's try theta equals 20 degrees. Same thing. I go up again. I hit enter. And I change the 25 degrees that I put before, and I put instead of 25 degrees like I put before, I'm gonna put 20. That's my new guess, and I'm gonna put here 20. There you go, 0. That means that the angle that I was looking for is 20 degrees. And once you have 20 degrees, you just get this and put it into there. So it's going to be 60 cosine 30 divided by this for t. Let's calculate t. T is going to be, in that equation, 60 cosine 30 degrees divided by cosine 20 plus cosine 20 plus 20, being this, that 20. And that will give the value for t. So it's going to be 60 cosine, in any equation, in the top or in the bottom equation, 60 cosine 20, cosine 30, I'm sorry, divided by cosine 20, close parenthesis, plus cosine 40. And that will be 30.46. The value for tension should be 30.46 pounds. You see, that's a straightforward method, and theta equals 20 degrees. It's straightforward. We haven't done anything. The only difference here is that the way you are solving the system and establishing the system, that is trial and error. That's easy. That's not complicated. It's just applying trial and error and applying the equations. And important thing is that you know how to put these parentheses and everything in the calculator, because otherwise it's going to be a mess. You could have done this problem differently, but I'm not going to solve it. You can rotate it like that and say, okay, I'm going to use this as x prime, and then I'm going to put my y prime here, and it's going to kind of simplify a little bit more, but the rotation itself, I don't like it in this problem. I'd rather go in traditional in this way, because it's not going to help me too much to rotate that those axes in this problem. Check this problem out. Try practicing trial and error, because trial and error is huge. The majority, not the majority, but a lot, I would say the majority of the algorithms that look for solutions, they work in trial and error. So see you next video, guys. Thank you.